Hey guys, welcome to another screencast of my Built on AWS series. Earlier, we hosted a simple HTML file on S3 bucket. Then we hosted an Angular application or React application or Vue.js application on S3 bucket and served through CloudFront. But for the most parts, today's front end do not stand alone. They always rely on an API or an backend. So in this episode, we are going to add a serverless backend with local development support. Let me go into my presenting mode. Okay. So at the moment, we have this architecture. So our web application is hosted on S3 bucket and it was served through CloudFront. So how can we tag along our API? So in that case, we will introduce another path pattern to our CloudFront distribution. So whenever a user or the web application is requesting through a different path like /API/ something, it will be directed to the API. For example, if there's a path pattern like www.myapp.com/API/todos, then this path matches. So the request will be directed to the API. So inside the API, it will trigger a Lambda function. So Lambda function is a serverless function that will execute whenever a request is reached. So it will execute the business logic and it will go away. So when it comes to executing the business logic, it includes talking to a database and get the response and send it back to the website. So this is the part we are going to look at in today's episode. So our full architecture is a serverless architecture because our API gateway is serverless, S3 bucket is serverless, CloudFront is also serverless because we are not managing any servers but using some managed services from AWS. Okay, so let's go on and start or create our API. Let me go into my AWS console. But in this time, I'm not going to go to API Gateway service and create an API from my console because I want to keep my infrastructure as code in my project because I'm working with my team, so they also want to spin up their own API Gateway in their AWS accounts. So it will be difficult for them if I use the console to configure it. So I'm not going to use this. In AWS, we have CloudFormation service to have our infrastructure as code. CloudFormation is really great, but there are other frameworks that is built around CloudFormation which are more developer friendly. For example, serverless framework. So let me go into their website, serverless framework. So this is one of the frameworks that leverage CloudFront to automate the infrastructure. This is very developer friendly. And AWS themselves, they have developed or they have released another application model that's called SAM or Serverless Application Model. So this is another kind of wrapper around CloudFormation. You can see I am on their GitHub page. So it's SAM, AWS SAM. You can use SAM to automate your infrastructure. Now the specialty here is AWS SAM also support local development. We have SAM local. Let me just go into that SAM local AWS. So what do I mean by developing locally? Normally, when we develop our application, we have to just publish or deploy it to AWS to test it. But as developers, we don't want to always deploy it to AWS and test it. It will take time and it's difficult to debug the application. So SAM Local provides a really great way by emulating all our Lambda functions locally as well as API Gateway and DynamoDB. But today I'm going to focus on serverless framework. Serverless framework also has some local development abilities. So let's start with serverless framework. So I'm going to go to quick start docs, and there you'll see serverless framework supports multiple cloud providers. This started off with Amazon Web Services. So let me choose AWS. So in their quick start guide, you have some prerequisites. Basically, you have to have Node.js and you have to have Serverless CLI installed. So to get started, first of all, we need to have Serverless CLI installed. Let me just copy this command and go into my terminal and paste it here. I'm not going to press enter because I already have it installed. Once you have installed it, you can check its version by simply typing serverless-v. I think I have one of the latest versions, it's 1.2.26.0. Alright, so let's follow along the quick start. As the next step, we can create a new service. Now, new service is basically another API gateway, and we can attach Lambda function to that. So let's try to create a new API gateway by using this command. I will go back to my terminal and let me see where am I right now. I'm on desktop, and I will create a new directory, mkdir test service. Okay, and I will go to test service, and here I will just copy paste this command. It says serverless create -- template AWS Node.js. So I want a Node.js project, so that's why I selected the template as Node.js and path my service. Basically the name of my service. Okay, let me press enter, and it will quickly scaffold a new template. Okay, so let me go into that folder and I will open it with my Visual Studio Code. So when you have a new template in serverless, you have two main files. First one is serverless.yml file. So this is the place we will list down all our configuration with respect to our API gateway and Lambda functions. So if you can see, let me just take out these comments. Firstly, you have the name of your service, and then you can configure the provider, and the runtime is Node.js. Let me just scroll down here. So this is the place where we will define our Lambda function. Okay, so at the moment there's a default Lambda function called hello, and the code for that Lambda function resides in handler.hello file. So that's what our handler file is for. So in our handler file, we'll define the code for our Lambda function. So in this case, the hello function contains this response. Okay, so whenever someone is invoking this Lambda function, this will be returned. Now if we just look at this commented code, there's something called events. See this one. So this is basically how you can tag a Lambda function with an API gateway. So let's tag our Lambda function with the API gateway by simply uncommenting these lines. So what does this say? So I say, okay, attach an API gateway route or path called user/create. Whenever a user is visiting this path, render or trigger this function. So let's actually change this to hello. Okay, so that's how simple it is to configure our API gateway and a Lambda function related to that. You see, it's less than, let's say, about 10 lines if you leave this space away. Okay, now how can we deploy this? Let's go back to the quick start, and you'll see there's a simple command to deploy it. Let me copy this one, and I will open my integrated terminal, and I can simply say serverless deploy. Now before doing that, make sure that you have configured your AWS CLI, and I think we have done it in a previous video. So basically, once you have configured your profile, you can simply refer it by using profile tag or profile attribute. I have a profile called YouTube, so I'm tagging that particular profile. Okay, now you can simply say serverless deploy. I will press enter. It will basically package the service, and it will create my API gateway by looking at this event, and it will tag this particular Lambda function to my API gateway. It will take a little bit of time. Let's see. Now it's uploading the CloudFormation template to S3, because normally CloudFormation accepts an S3 URL. So that's what this serverless framework does behind the scene. So it will package the file and the Lambda function and upload to S3 bucket, and it will use CloudFormation to spin up all the infrastructure related to that, in this case API gateway and Lambda. Okay, let's wait for this. Alright, now it's completed. So if you see the console output, you can see the endpoint of your API gateway. So it is this one, and the function that is tag along with that. Now if I just simply click this endpoint, I should be able to invoke my Lambda function. You see, it has invoked it. You can see our message here. Let me of course take out this input content. I will simply go here and take out this input or event information. So once you have edited your Lambda function, you can simply do serverless deploy again, or you can deploy that particular function only. So in this case, I deploy the whole stack again. Okay, it has updated my API gateway and my Lambda function. So let me just go ahead and refresh again. Now you see it will only show my message. Great. So let's get into our API gateway and see if it has actually configured an API gateway for me. Alright, I think I have to be on that particular region. Yeah. Since I have not mentioned a region here, so I can of course mention a region like EU West 2. I can do that and deploy it, but since I haven't specified it earlier, it will choose the default region as US East 1. So in that case, you'll see my API. So that is called dev my service. Now this dev is a prefix of my stage. So those are some default behaviors of serverless framework, which of course you can override it. You can say whatever the stage name, like prod. So once you said that, it will be prefixed with prod. Now let me go into that, and you'll see the API uses hello. This is the path, and it's a get request. Once you click that, you'll see whenever someone is invoking that path, so they will ultimately reach to the Lambda function, which of course the one I configured it earlier. And if I click on that link, it will take me to the Lambda function. It's loading my function. You see, it is the very same code we have seen in our handler.js file. Okay, now if you want to remove the infrastructure like API gateway and Lambda functions, you can simply use serverless framework. You can simply say serverless remove. Now this will remove your stack and all the infrastructure that it has previously provisioned. Right. So that's a quick introduction to serverless framework. Now it's time to create a simple application. Now let's create a to-do application with local development support. And I'm not going to do a live coding session, but I will use a boilerplate which I have created sometimes back. Now that boilerplate name is serverless React boilerplate. If you just type it into the Google, you will reach the GitHub URL. Let me just go into that. So it's on this URL. So this is basically a React application which has a API gateway backend with DynamoDB as the database. And it's a simple to-do application where you can put to-dos and you can edit it, delete it, and mark them as completed. Simple to-do application. Now these are the features. So it basically supports 1.2.26.0, the latest one, and it will support offline development with DynamoDB, Lambda, and API Gateway. And it will support local DynamoDB seeds and migration. So this of course means you don't have to deploy the infrastructures onto your AWS to test it. So basically you can test it on your local machine with local DynamoDB support. So let's get started and go ahead and clone this URL. Just copy it and let me go into the terminal and I will go into my desktop. Okay, I will create a new directory, my boilerplate, and I will just cd into that and I'll say git clone and paste in that URL. Alright. Now let's go into this particular folder, serverless React boilerplate, and there are some files. I will open it with Visual Studio Code. So in this project directory we have two main folders, API and web. Now web is where our React application resides and API is our API gateway and Lambda functions. So I will first go into the API directory, and in that we have a to-do folder which is our to-do service, and we have an API gateway for to-dos. So this is the serverless YML file, and now don't get too intimidated by all these configurations. Now these are very simple configuration. As you can see, the service name is to-do and the framework version, the provider. So in this case AWS Node.js as we have seen, and I'm using the profile default. Now let me just change it to my YouTube profile, and stage is dev, and region EU West 2, which is the London region. IAM role is basically the role applied to the Lambda function which is attached to the API gateway. So a role basically does is, what the Lambda function can do. Basically the Lambda function in this case, it can access DynamoDB. So that's what the role defines. And the environment variables here, so I have app secrets and DynamoDB prefix. And then I have plugins. So these are the plugins that I use for local development. I have serverless DynamoDB local plugin which emulate DynamoDB locally in my machine, and also serverless offline plugin which look at my API definitions of my API gateway and emulate the same API on my local machine. So these are the two plugins that makes local development possible. And I have another tag called custom where I will list down the configuration with related to my local DynamoDB plugin. And then I have the section of my serverless Lambda functions. So I have like how many? Let's say 1, 2, 3, 4, 5, 6, around 6 Lambda functions. So those are related to my application. First one is about getting all the to-dos, right? So in this function, the handler is pointing at handler.getAll to-dos. So there's a path involved as well. For example, if someone is visiting my API with the paths to-do/getAll, they will trigger this Lambda function. So this Lambda function resides in handler file. So let's go to the handler file and this get to dos. So it will invoke this function. So let me go into this. Now what get all to dos do is it will return all the to dos. Now there's another function inside that here. So this is basically returning all the to dos in my DynamoDB table. So it will use scan operation on my DynamoDB. Okay, and there are other functions like create to dos, and if I go to my handler, create to do is this one, and it will call this method create to dos, and it will call helper.create to do method, which will basically put a record into the DynamoDB table. Yeah, so it will use put operation on DynamoDB. Now this DB instance, I have references from an external file, so where it resides in this database folder, so which is of course this one, and this DynamoDB.js file. So this is basically the DynamoDB instance. It will return a DynamoDB instance. First of all, it will check whether am I in the offline mode or am I actually using it in production. So that is being checked with this particular environment variable, or if you are in the offline mode, this variable will be true. So if so, then it will use a different configuration for the DynamoDB. Basically the DynamoDB local will be instance will be written. Otherwise, it will use normal DynamoDB instance. Okay, I think you can just go into these details if you have a look at this boilerplate. And there's another section called resources. So this is basically other resources that we need to have our application running. For example, at the moment I have API Gateway and Lambda functions. So what other resources do I need? So at the moment I'm referring to one of these YML files. So this is located in my offline folder, this one, and inside migration, and there's a todo.yml. So this is basically a DynamoDB table, right? So we are provisioning a DynamoDB table. You will see this is just CloudFormation syntax. You will have the type DynamoDB table, and the attributes or the fields like the ID and the provision throughput and everything else. You can go to the AWS documentation and see all these configurations. Okay, and when I'm packaging this, I'm excluding some of my local dependencies. So when I'm packaging this and deploying it to AWS, I'm removing my DynamoDB local host and Serverless DynamoDB local and other offline plugins. So that's a quick walkthrough about the boilerplate. Now let's try to use the local development. So in order to do that, you first have to run npm install, because you have to install all dependencies of your API and as well as web application, which is our React application. if you just open a package.json file, you will see inside the script section you can simply type npm install. So let's go ahead and type npm install. First of all, it will trigger the pre-install, which will of course go into the web folder, which is my React application, and it will run npm install inside my web application here. So it will install all the dependencies my React application requires. For example, Axios and the foundation sites, which of course another CSS framework, really good one, and jQuery and Lodash, everything. So, and the post installation, it will go into my API directory, and it will go into my to-do directory here, and then it will find the package.json and run npm install there. So in here it will install all the dependencies, for example AWS SDK and Bluebird, which I use for doing promises. Okay, great. Now it's finished installing all my dependencies. Well, something went wrong somewhere in the middle of the installation. Maybe my internet was not connected, so I had to run it again. Anyway, now it's all completed. Now we need to run our application locally. In order to run our application, we have to have local DynamoDB setup as well. You can simply run db setup script. Let me run npm run db setup. So this will of course download a DynamoDB local and install it on your local machine. So let's wait for it. You see started downloading DynamoDB local, and this will take few minutes. Okay, great. DynamoDB local setup is done. Well, it took me about 3 to 4 minutes to download the executable and install it. Now that we have everything set up, let's try to run our application locally. In that case, we'll run this script, npm run app, so which will run a gulp task internally. So this gulp task will serve both our front end, and it will spin up the local server by looking at our API gateway, the definitions. You see the DynamoDB local started, and it will automatically open your web application on a local port. Alright, great. So you see I have already configured some seeds. Like I already have some pre-built tasks, and I can add new task as well. New task, and press enter. It will be added. I can mark them as completed, edit it, save it, and then now if I refresh it, it will persist because this is now stored in my local DynamoDB. Yeah, I can delete it. I can do everything. Yeah, I will show you where I have configured the seeds. Let me go into my API folder, and there you will see a folder called offline inside to do folder. There's this to do seeds. So these are my seeds. So basically everything you have seen when starting up the application will be based on these seeds. Okay, great. And how can you do the local debugging? Now let me give you an example. You see when I run the server, or when I run that script npm run app, it will start some command line output on my console. Yeah. So let me of course go into my Lambda function. My Lambda functions resides in to do folder and handlers.file. Yeah. So let's see, creating a new to-do. Yes. So I will just come here and I will just uh, console log some statement. We are creating a new task or to do. Okay, I will save it and let me use spectacles to get my code to the left side, and I will have my browser to my left side and the code on my right side. Okay, now let's refresh it, and let's set a new task or new to do. My new to do. Okay, when I'm adding the new to do, you will see on the console that our console log is printed, right? Likewise, you can do a lot of debugging. You can add debugging point and do your local testing even before you publish it onto your AWS. All right, now suppose now we are satisfied with our to-do application. Now we are about to deploy it onto AWS and deploy my React application as well onto AWS. So how can we do that? Deploying our API is quite easy. That we can easily go into our API folder, in this case to-do folder, and run a serverless deploy. Let me just go into my API and I will go into to-do. Yeah. Now I can simply run API or serverless deploy. So then it will just provision all my infrastructure onto AWS. Make sure you have changed your profile information where your AWS profile is configured. Alright, so I am deploying it onto EU West 2, which is London region, and I am expecting it to create my resources, which of course my DynamoDB table, and create my API gateway with all these event paths and the Lambda functions which are linked with those paths or API gateway. Alright, so let's say SLS deploy. You can say serverless deploy or in short SLS deploy. One thing you should notice is this environment area. So this is basically where we configured our environment variables. Yeah. So basically all your app secrets, database prefix can be referred inside your Lambda functions. You should not hard code them in your Lambda functions, but configure it or use it through environment variable, which of course is the best practice. In this case, I'm using config.yml, which is residing here, and I am referring to these environment variable depending on the stage selected. So that's what I have mentioned here. So I will go into my config.yml, then I will go into the particular stage that is selected and then get the app secret variable. Okay, serverless deployment is completed. Now it has shown all the endpoints of my API gateway and all the functions that it has deployed. Now let me go into the region, London region. Okay, I'm on London region. Click on get started, and if you click APIs, you'll see dev to do. It's my service name prefixed by the stage name. If I go into that, you'll see all the API gateway results: to do, delete, get all, status, update. They are corresponding to the paths that I have given here. Yeah. Okay. And each of these paths are linked with the corresponding Lambda functions, you see. Okay, now I want to do one thing. If you can remember, earlier we have configured our S3 bucket with CloudFront Distribution. So if I go into my diagram here, you see I have to configure another path pattern that is directing to my API gateway. So I have to create another path pattern on my CloudFront. So let's quickly go to CloudFront. I will open it in a new tab, and I will click on dashboard of my API gateway, and from there I can copy the URL of my API gateway. I will copy it and I will go back to my CloudFront distribution. You'll see this is my CloudFront distribution. I click into that. At the moment I have only one origin, which of course my S3 bucket where my web application is hosted. So I will create another origin. So the domain name is the domain name that I just copied from API gateway. Make sure to remove the last /dev no stage. Just remove HTTPS part as well. So we have only this part. Okay, right. Then you can name your origin. Let me say to do API. Okay, and you can say the protocol is HTTPS only because I want it to serve through HTTPS. That's it, and create it. This will create your API gateway origin. Yeah. Now let's go into behaviors. I need to create another path pattern, which of course /dev /anything. Yeah. So if the path pattern contains /dev /anything, then it should go into my to-do API. Why? Because and everything is prefixed by /dev. Okay. So if there's any path starting with dev /anything, take that to my API origin. And you can select HTTPS only and make sure to speak get, head, put, post and all these HTTP method, because we are getting and we are posting, creating, deleting the to-dos. And one of the important thing is this object caching. Make sure to click customize and set the maximum TTL and default TTL to 0. Why do I do that? Is basically the CloudFront will otherwise cache the requests, but I don't want to do that for my API. Why? Because I want to get the latest content from my DynamoDB as soon as the new request is made. But in my web application or the React application, of course, it can cache the content and send it from my CloudFront distribution. Okay, so that's it. And let's say, okay, forward all the cookies and forward all the query string back to my origin or back to my API gateway and just create it. So you might be wondering, why did we tag our API onto CloudFront without just using the API gateway domain in my React application? The main reason is to avoid cross-origin resource sharing or cross requests. Normally my S3 bucket is hosted at daytodaycode.com. Yeah? So this is my S3 bucket. My API gateway URL is now different, this one. Now if my React application try to access this URL, it is not allowed. If I want to access it, I should be able to use the same domain. So that's why I'm using /devpath or devpath to do and get all. So this way we can avoid cross-origin requests. think we are good to go right now. So let's see, my CloudFront distribution status is in progress. Okay, great. So meanwhile, let's go ahead and deploy our front-end application or React application onto our S3 bucket as well. So at the moment, you saw that it's just some HTML, but I want to have my React application, this application, which is hosting at the moment on locally, to be up on my S3 bucket. Yeah. This is very simple. We saw that in the previous video. What you can do is you can simply go to our web application folder and go to package.json here, and you can simply copy paste a script. Let's name it as deploy S3, and the code is, and let's copy paste this code. It's AWS profile. The profile name is YouTube. In my case, you guys say your profile name here, and S3 sync. The folder path, when you build the folder, I think it should be /build, and the bucket name is day-to-day-code.com, and the region is EU West 2, which of course the London region. Okay, I'm not quite sure about this the build folder, so let's actually build the application and see the name of the build folder. You can build the application by running this script. Make sure you are in the web folder, and there let's run npm run build. When you run this command, it will build the product or the web project. Yeah, the folder name is build, so I think I'm correct here. Okay, it has finished building product. Okay, now let's use deploy S3 command to deploy it onto my S3 bucket. Let me run npm run deploy-s3. This will use my profile, AWS CLI Profile, to upload the content inside the build folder, which of course some HTML, CSS and JavaScript file, onto my bucket. You see it's getting uploaded. We saw this quite in detail in the last video. Alright, now I think if you can remember, we have to do one more thing, which of course is invalidating the cache. Let me just copy paste one of the code from the previous video. Okay, this is basically to bust the cache of my CloudFront distribution. YouTube, my profile name, CloudFront create this invalidation and distribution ID. Let's go to my CloudFront, and my distribution ID is this one. I will replace it. Alright, and distribution ID and the paths. Now let me run npm run cache bust. Yeah, now it's going to invalidate the cache of my web application. So see, the status is in progress. Now if I go to my web application day-to-day-code.com, and I will open up the developer tools, and let me just refresh it. Alright, great. You can see now it's created, but still again you see the tasks are not appearing yet. Now there's a reason for that, because we forgot one step. We actually has forgotten to update our web application with the URL of our API gateway. Now let's quickly go ahead and do that. Let me go to source and let me go to app.js file, and you see our base URL for our API is still referring our local path. So let me just copy it and comment it out, copy paste it again, and let's replace it with our API base URL. So our base URL is nothing but day2daycode.com/dev. Alright, so basically our base URL is this. So whenever we use Axios to talk to our backend, it will use this base URL day2daycode.com/dev, and it will append the rest of the path /to-do/get-all. I believe this is it. So let me go back and let me build my application again. npm run build. Okay, now let me run npm run deploy-s3. This will upload my latest code onto my S3 bucket. And let's run npm run cache bust to invalidate the cache. Alright, let's see. I will open up my developer panel again and click and hold this refresh button and select empty cache and hard reload. I think now it's fine. You see, it doesn't show any task yet because when our AWS infrastructure is provisioned, serverless framework, deployed API gateway, lambdas, and a DynamoDB table. If I go into the DynamoDB service, you will of course see that provision table. You see, if you click tables on the left menu, you see there's a table here, dev to dos. If I click on that and click items, at the moment there are no any items. Alright, so that's why it does not show any items here. So let's add a new item. Record a video. Okay, and sleep. Okay, so I added 2 of these tasks, and let me mark one task complete, or let me mark this task complete. And if I go back to my DynamoDB and do a refresh, you'll see the content is now available on my database. Okay, I think that's basically it. So we saw how to develop our application locally by using serverless framework, and then once we are sure our application is ready to publish, we publish it. Now it's working online. So that's it, what I want to show it in this video. Maybe in the next video we'll add authentication using AWS user pool and custom authorizer. So that's it for this video, and I will see you guys in another video. Thank you very much.